Hello, students. In today's online ATL session, we are going to learn about the Tinkercad electronics software. We have used Tinkercad for designing, but today we are going to use it for electronics. And along with that, we are also going to do same circuits hands-on and see that they work the way they work in Tinkercad. So first sensor that we are going to use in today's session is basically a PIR sensor. All of you might have used this PIR sensor, which is passive infrared sensor. It measures the infrared light from radiating from the object, and it is mostly used for detecting the motions, like security alarm and automatic light applications. So how it works? It detects the animal or human movement, and it has a pyroelectric sensor, which basically generate electricity upon receiving the infrared radiation from humans or any other living beings. So let's make this first circuit of PIR sensor and LED using breadboard. What we need is basically PIR sensor LEDs and jumper cables, jumper wires, and also 1.5 volt battery. This is how basically in Tinkercad you log in, then go to circuits. Uh, we will see this window basically has all the parts on the right hand side, and the middle one is basically a working window. We have taken the breadboard first as one of the parts required. We need three of such 1.5 volt batteries. So it is going to be 4.5 volts in together when we are going to put them in this circuit. So three of such batteries we need. So definitely a battery holder is needed. We will need a resistor of one resistor of 220 ohms. So we have made that 220 ohm resistor. We need an LED. So we have taken one LED from Tinkercad part list, and then PIR sensor. So this is how basically a PIR sensor it is located into the Tinkercad. So now let's arrange all the parts as per our requirement. We have connected the negative terminal of the battery to the breadboard, marked it as a black color as standard ground connection. Then positive terminal of the battery is connected to one end of the breadboard. Let's make it as a red color, being it a positive terminal. Then zoom it as per your need. Arrange the wirings as per the placement of the object into Tinkercad. So let's get the PIR. Now let's see what are the terminals. The first terminal is ground. So let's connect this ground terminal to the ground terminal on the breadboard, and let's make it a black as well. Now another terminal of PIR sensor. So that is signal and this is power. So this positive signal, positive terminal, that is power terminal, we are going to connect it to the positive terminal and make it red. Now let's connect the resistor to the negative terminal. So 220 ohm resistor is connected to the negative terminal. Orient the LED in a such a way that we are able to make the connections. So the negative terminal on the breadboard side now, and we have connected the negative terminal of the breadboard through resistor, and positive terminal of LED is connected to the breadboard. Let's change its color, purple color, and connect the signal terminal of PIR to that positive terminal of LED. So we are almost done with connections. Start simulation. Play that button. Start simulation. Now you will see one blue color dot, which is in the range of PIR sensor. As you move it out of the range, the light LED will glow off. And when you bring the that dot ball into the range, the LED will glow on. Now we can make the same circuit without breadboard as well. We can make direct connections. We don't need the breadboard. you can see the part list here, and we have just connected the terminals without using breadboard. Now let's see the same circuit using Tinkercad without breadboard. As we have said, we need 220 ohm resistor, then LED. I'm not going to rename the parts. Three batteries of 1.5 volt. So now, quickly, as I said, when any object comes into the range of PIR sensor, it will generate the electric signal, and that's how the LED was turned on. Now let's put the parts here as well as per our need into Tinkercad. Let's reorient the register as per the requirement, and again checking the terminals of PIR sensor. Let's connect ground to the negative terminal of the battery directly instead of using the breadboard. Mark it black color. Then let's connect the negative terminal through resistor again to the negative terminal of the battery, and then positive terminal of the LED is being connected. Positive terminal of the battery is connected to the power terminal. Mark it red color, and then positive terminal of LED is connected to the signal terminal of PIR. Now again start simulation, and as I bring the that blue ball inside the range, the LED will turn on. When the ball is taken out of the range, the LED turns off. This is how actually hands-on that same circuit has been done hands-on. Breadboard, PIR sensor, battery holder with three batteries, register, LED and jumper wires. We have put the three batteries with 1.5 volt, connecting negative terminal at one end, positive terminal of the battery onto the another end, so that we know that all of you know the breadboard basics. On top and bottom of the breadboard, one straight line along the length side of the breadboard has that same terminals. So we have just checked which terminal of PIR sensor is positive ground. Now let's connect the white jumper wire that to the positive terminal, that, and then let's connect the ground terminal to the negative terminal of the battery, that is ground terminal of PIR to the negative terminal of the battery. Then we are also going to connect the resistor to the negative terminal on the breadboard. So 220 ohm resistor. In actual practice, just make sure that you are going to either trim those terminals of resistor or bend as per your convenience. Just put into that negative terminal and then bring that across the other side of the breadboard, 220 ohm, and then take LED. Yeah, negative terminal of LED is connected through the resistor, and positive terminal of LED is brought on the other half of the breadboard. Now let's connect the signal terminal of PIR sensor to that positive terminal of LED. This is how our connections are made. Turn on the battery and let's check. Yeah. As we move hand in front of PIR sensor, the LED turns off and it is turned off. Now another circuit that we are going to make in Tinkercad and also on hands-on is LDR sensor using LED, LDR sensor and LED using breadboard. So LDR is light dependent resistor. As the light is fallen on the sensor, it will turn off the circuit. Now let's go to Tinkercad new circuit. The parts that are needed into this is basically a breadboard, a photoresistor or LDR basically. Then we need 4 resistors, 3 of 1 kilo ohm. So resistor 1 of 1 kilo ohm. Same thing we will do register 2 and 3 of 1 kilo ohm. Better you rename them. I'll also explain the importance of renaming the parts. You can download the BOM and you can also create the circuit diagram directly from Tinkercad. The fourth resistor is to be 10 kilo ohm. You have taken 9-volt battery and LED from the part list, and we need NPN transistor, that is BC547 transistor. Now let's arrange the parts as per our convenience. We have put the LDR first, and then we have grouped 3 resistors of 1k kilo ohm, and let's put the transistor onto the breadboard. You can reorient the resistor as per your convenience, the 10k ohm resistor and then 1k kilo ohm resistor. We have put the LED as per this orientation, and now we are going to put another resistor. These two are 1 kilo ohm resistors each, connected to the positive terminal of the LED, and these resistors are connected in series. Now we are ready to start connecting the terminals. Now ground connection we have given to the ground connection of LED and marked it black as per the standard for our reference. Positive terminal of the battery is now connected through this one resistor. Mark it as a red color. Now let's connect the LDR to resistor to LED basically. Now let's connect the negative terminal of LED to base of the transistor. There are 3 terminals: base, emitter and collector. Now base is connected. Now let's connect this resistor to the rightmost terminal of the transistor and third terminal of now there is one more terminal of transistor needs to be connected to the LDR. Now we'll directly make that connection and give it a different color. Now we are almost done with the circuit in Tinkercad. So now let's click the button start simulation, and on LDR you will see that bar. You have to turn the light on, and you can see the LED is switched off as the light falls. When there is dark, the LED turns on. Now hands-on, you see the part list, same part list as what we have taken into Tinkercad. Breadboard, jumper wires, LDR, resistors, 3 of 1 kilo ohm, 1 of 10 kilo ohm. So let's start making the assembly as per the instructions. The LDR is connected. We are exactly making the same circuit actually on the breadboard, the way that we have made it on Tinkercad. So you can refer this video later also, to watch it slowly and make those connections as per the Tinkercad circuit or as per this hands-on circuit as well. Now we have put the BC547 transistor. This transistor is there in the ATL lab inventory. Now all the parts are assembled. Now start making the connections using the jumper wires, exactly same as that of the Tinkercad circuit of LDR, sensor and LED. You can play and pause this video to refer to the circuit. Right now, because of the time limitations, we are running it, and just want to show that how the circuits are made using Tinkercad and hands-on using the breadboard. Now all the connections are made except the battery. Now battery cap, positive terminal, negative terminal is now given at one end, and the other terminal. Now we have connected the battery. Now a light is turned on. Now when we put the flash on the LDR, the flashlight on the LDR, the LED will turn off. When the flashlight is turned off, the LED turns on. Same thing you can do in Tinkercad without using breadboard. This circuit you can also try. We have not connected in hands-on. The next circuit that we are going to make is traffic light. All of you might have done this using LEDs and Arduino. Specifically, we are going to use breadboard. You need Arduino or Uno LEDs and breadboard jumper wires. Let's go again into Tinkercad, click plus new circuit. Let's bring breadboard and three LEDs, red, yellow, and green, because they are traffic light LEDs. So let me make the first one red again, and this one yellow, and then another one green. What we need is basically Arduino Uno board here. Let's arrange the parts as per convenience. Ground connection of Arduino is been given to the ground for ground connection to that breadboard. Let's arrange all the LEDs as per our convenience. First, red LED, connect that ground connection. Let's give ground connection for each LED through that common ground connection on breadboard. Third LED also, same thing, ground connection for that green. You can move, rearrange the parts just to make sure that your circuit looks better into Tinkercad. Now, let's give the ground connection is been given to the signal pins now. Green LED signal pin is given to digital pin number 2. Yellow positive terminal is connected to digital signal pin number 3 on the Arduino, and red LED's positive terminal is connected to number 8 digital pin on Arduino board. You can change colors for all three wires, so that it is distinguished easily. Now we have made all the connections. It's time to basically go to the code, because this circuit needs code. Select that code, choose text one instead of block or block plus text. Let's write the code ourselves. Go to code. You can start writing this using this. Instead of let's define integers LED, digital pin number 2 for first LED, integer LED 2 for the second LED, digital pin number 3, and third LED, digital pin number 8. So we have defined 3 digital pins as output pins for LED. Now let's define the output into void setup bracket. So let's define LED 2, LED 3, that pin number 2, 3, and 8 as output pins on the Arduino. And into void loop, we are going to basically write the commands for LEDs to turn high and low. LED 1 high for 1 second and then low. And then once the first LED is turned off, we are going to turn the second LED on. When the second LED is turned off, the third LED is turned on. So in this sequence, we have made the code. Let's click the start simulation button, and this is how green, yellow, red, green, yellow, red, all these LEDs are turning as per the sequence. Now you can try changing the delay, and again click start simulation and see, the LEDs are turning on only for half a second. Same thing we are going to do hands-on. Breadboard, 3 LEDs. I didn't find the red LED. So anyway, it doesn't matter. Connect the ground pin of the breadboard of the Arduino onto the breadboard. That is a common ground pin. Now connect all the ground pins of 3 LEDs, as a common along that line of the breadboard. Now the second LED ground pin connected through the same line, and positive terminal of each LED is being connected on the other side of the breadboard, which we are going to connect through jumper cables to the digital pins. Now let's take one jumper wire. That first LED positive terminal is connected to is now being connected to the digital pins. Just for convenience and avoid confusion, we are changing the jumper cable color here. Now after connecting the jumper cables to the breadboard, we are directly connecting them to the digital pins number 2, 3 and 8. First LED number 2, the second LED to number 3 and third one to number 8. Once the connections are done, we are going to connect the Arduino to the computer using the USB cable so that it gets power on, and we have loaded the program into the Arduino already. There is some pins are the sequence has changed, but anyway we will change the pin numbers because in the code it might be little up and down, the actual code that we uploaded. By changing the cables and the pin numbers, we get the sequence like this. Now we are going to use servo motor with Arduino. Servo motors are basically used in robotics to turn the motor at a specific angle with a specific duration. So what we need is Arduino servo motor and jumper cables. Go to Tinkercad and there is a select this Arduino button on Tinkercad. You will get all the Arduino standard circuits. Bring the servo circuit. Now this is a signal pin, green wire, that is signal pin. Then this is a power, that is positive terminal, then the ground terminal. Now there is a code already given. Again, select text. Now this code basically tells about you have to define include servo.h. Then you have to define the servo digital pin number 9 and then attach servo. So this command is important, attach servo, and then we are going to turn the servo motor from 0 to 180 and 180 to 0. So this is a code. Start simulating the code, and the servo motor will run from 0 to 180 and 180 to 0 without any delay. So this is how you can use servo motor using Arduino, and actual hands-on you will see the same parts in the servo motor, Arduino jumper cables, the USB cable for Arduino. Let's start making the actual connection. Pin number 9, digital pin number 9, then ground connection. This now we have connected ground, and the 5-volt connection. This blue cable we have connected to the 5-volt terminal on the servo motor. So now let's connect the jumper wires to the servo motor. So positive and ground are connected now. The dark brown on the servo motor is basically ground connection, and then signal pin is connected. Now we have already loaded the same program in Arduino. I'm not going to show that here. Connecting the Arduino to computer directly. The program is already there, and this is how basically the servo motor will turn from 0 to 180 and 180 to 0. Next thing that we are going to do is we are trying to dim the LED brightness, increase or decrease using potentiometer and Arduino. Potentiometer generates, or it is a variable resistor. So let's see. There is a standard circuit using Arduino, and select analog in and circuit. Basically there is a code already there. What this code tells is basically let's rearrange the parts and let's see the code again. Yeah, so that we see all the components and code. So there is analog pin A0 which is input, and then 9 pin number as output through resistor. So what we have said here is read the analog value from the potentiometer and change the output. So change the digital value, and accordingly the LED will either start dimming or increasing. Now we are also going to use the serial monitor or Tinkercad. As I turn the potentiometer and Tinkercad, you will see the values are changed. So at extreme end of the potentiometer, that is 1023 sensor value, the output is 255. So the LED turns bright and it will turn off. Same thing that we are going to do using hands-on. We need 250 kilo ohm potentiometer. So all the ATL labs have this potentiometer. Now we have already done this, soldering the three terminals of potentiometer through the cables. So now positive, ground, and analog pin of potentiometer. This is variable resistor. Now let's connect first the positive terminal. Now connect the ground terminal of potentiometer, the analog terminal of potentiometer, and lastly the ground terminal. So that is a negative terminal of potentiometer. So positive, ground, and analog input of potentiometer are connected to Arduino. Now we are going to connect digital pin number 9. We are going to connect digital pin number 9 to LED's positive terminal. LED, we are going to put it on the breadboard. Now we will connect ground terminal of LED. Yeah, now let's first connect the positive terminal of LED to the digital pin number 9 on Arduino. So number 9 on Arduino we have connected, and then ground connection been given to the ground negative terminal of LED. So there is another ground terminal on pin on Arduino. So we are going to use that second ground pin on Arduino for LED. We have already uploaded the program, and just connecting the USB of Arduino, and we will connect it to the computer. Now as we change the analog value of potentiometer, the LED will start brightening. At 1023 sensor value, 255 outputs, that LED is the brightest. As we turn it off, turn it other way, the sensor value reduces from 1023, and output value is also reducing from 255 to 0. So LED you can dim or bright. Thank you for watching this session. Do you have any questions? Please post them on the channel. I am available on the channel to answer your questions. And thank you very much. I hope that all of you will, try this Tinkercad electronics section, and also make these circuits hands-on, so that you can verify the Tinkercad electronics before you actually make your connections. So thank you very much.